everyone, I'm Kelsey Conophy, chatting to you today from Bozeman, Montana. And I'm really excited to chat to you about using design thinking to drive innovation in the age of AI. Before we do, just a little bit about me. I've worked in the technology industry for over 10 years as both a product leader and an entrepreneur, and have leveraged various different applications of AI and machine learning for different products or functionality, from demand forecasting systems, supply chain optimization, recommender and personalization systems, to many, many more. And really, where my love for design thinking started was when I was studying design and management at Parsons School for Design in New York City. Really, since the day that I learned about it, I got hooked. And I would say pretty much every product, every project I've worked on, I've used at least some aspect of the design thinking process. And I'm really hoping to get you all just as excited about design thinking as I am, and give you guys the tools to build innovative products moving forward. So what is design thinking? Well, at its core, it's an iterative problem-solving approach that leverages a user-centered perspective paired with research and rapid prototyping to create holistic solutions that address user needs. And some of you might be thinking, well, I build AI products. My users are systems. I don't need to worry about humans. I should just stop listening and join another session. And that would be incorrect. If you think about even, I have built and been on teams that build models for system-to-system communications or interactions. And even at the end of the day, there's an end desired human outcome that we're trying to produce. There's a human process most of the time. Even if there's high automation, there's some sort of human at some point, oftentimes, that interacts in some way, shape, or form. And so this design thinking is even relevant for those types of projects and initiatives that are even system to system, but particularly relevant for human-focused products as well. So how is this relevant specifically to AI and ML initiatives? One of my learnings over the many years, and I'm sure many of you AI practitioners have discovered this learning as well, is that machine learning has really become the hammer looking for the nail. It's really easy for teams and particularly leadership to get really excited about machine learning solutions and really focus too much on the science or the model or the math, as opposed to trying to deliver the value to customers that's intended. Oftentimes also, I've seen AI solutions produce unexpected or unintended outcomes. And design thinking is a mechanism to ensure that teams take a step back and make sure that they're developing the right solution to the right problem and producing the desired outcomes. Additionally, one of the other issues with AI solutions is that oftentimes it's easy to assume that full automation and the absence of humans is the optimal solution. But really, through my own experience and what can be validated from many other successful companies, is that design thinking helps teams figure out where in intelligent systems, where do machine learning and AI add the most value, and understand when the human touch is still essential. Recognizing that not everything can or should be fully automated. And so again, design thinking is a mechanism to help teams pick apart what steps in a process, what aspects of a product are really important to infuse human touch versus intelligence to solve and produce the end desired outcome. Lastly, but definitely not least, AI typically, not like every other industry, is an industry of rapid change, adaptation, and innovation. And really one of the core values of design thinking is that it enables teams to look sideways, look around corners, and anticipate market needs, and think creatively about what systems or models previously built for other use cases can be applied to new areas and spun up really quickly to produce an impact. And this, with things like COVID, constantly changing consumer behaviors, ever evolving competitive landscapes, speed is absolutely critical. And design thinking is just one mechanism that enables teams to move faster. So how do you actually get started with design thinking? Well, taking a step back, when should you use design thinking? Again, I've used design thinking probably for every project, every initiative that I've worked on since learning about the framework. But it's particularly helpful to use to address high ambiguity, ill-defined problems. It's also particularly helpful when existing solutions are not producing the value that was expected, or when they're producing unexpected outcomes. And obviously, you can learn about a framework, you can learn about a process, but unless you have the right people involved, it's difficult to get the desired outcomes. And so the squad becomes really important. And particularly for design thinking, it's really important to have a cross-functional team of scientists, engineers, product managers, and product designers. And this looks different at different scales. So for example, if you're at a large company like Amazon or Facebook or Google, oftentimes there will be many individuals that are segmented into very different, distinct functions. But you might have a researcher, a data scientist, a machine learning engineer, a product manager, a UX designer, and a visual designer. However, at a startup, you'll probably often find that there are individuals that wear many hats and can perform many different functions. Sometimes all of these skill sets could be carried out by one individual or maybe two. So you could have what I've heard called a full stack data scientist. So it could be someone who has the skill sets to carry out research, carry out data science, but also has the machine learning and engineering skill sets to build and productionalize their models. And similarly, you might have a product manager who has a background in data science or has a background in product design and can play both the role of product manager, product designer, and potentially even sometimes data scientist or engineer. So again, it looks very different in different environments, but the most important thing is that you have all of these key functions cross-functionally on the team to produce the best outcomes. So getting into the details of the design thinking process, there are 5 key phases, and it's really important to note that the phases are not linear, they're not always sequential, and oftentimes phases are occurring in parallel. And they cycle through iteratively and they inform each of the other phases. So the 5 key phases are to empathize, define, ideate, prototype, and test. And we'll go into each of those in detail now. So the first step, to empathize, really the goal of the empathize step is to actually talk to users, observe interactions in the real world, could be of how humans are interacting with your product. The observations could be logs or other system observability mechanisms. Immersion is a really powerful tool. So again, if you have a highly complex process that you're trying to insert yourself into or build a product for, actually running through and carrying out that process yourself. If there's an existing product, dog food the product yourself, and obviously analyze data. And all of these are in the attempt to develop a holistic understanding of user needs, emotions, and motivations. Understand the process and the context within which your product exists or your solution could potentially exist, and identify how things interact in the real world. As everyone knows, the real world is unpredictable. And even when you're building system-to-system products, there can be many unintended consequences or unexpected uses of your original solution. So this step is really important to understand how are things actually working, and not just how were you intending things to work, but how are the users of your product or system actually interpreting it? How are they, what emotions are they experiencing? What motivations are they feeling as they're working with your product? The next step is to define. And the key aspect of what you do in this phase is to essentially coalesce and analyze all of the information that was gathered from the previous step. This can include process mapping or interaction mapping. And really the goal is to identify patterns, all with the intention of synthesizing all of your findings and insights into a human-centered problem statement. And the human-centered problem statement is really important here. It's really easy, again, with AI and research-oriented teams to get really hung up in the math, get really hung up in the research, get really excited about the model itself. But it's really important to take a step back and think about what is the human-centered problem we're trying to address here. If you're building a recommender system, it's not just to build the highest accuracy or most relevant product recommender system. The human-centered problem is, how do you help someone in their purchase decision journey to identify products that they love or that they'll really enjoy? And taking a step back and making sure you're thinking about that human need is really important. And why, it's really to define desired outcomes. So not only just make sure you're reorienting the problem statement around the human, but understanding what outcomes you're aiming to accomplish with the product, and sit down and explicitly state the assumptions that are at play with your product. This is really critical because it's really easy, again, to make assumptions, build assumptions into your solutions, into your models. But when you lose sight of what are definitively true facts versus what are assumptions, that's when you can get into a lot of danger. So the next step, once you have your human-centered problem statement, is to jump into ideation. And so really what this is brainstorm as many solutions that can be tested as possible. There are many resources online about different brainstorming techniques and tactics. So I won't list them all out here. We won't go too into detail. Just a quick search will produce a lot of results, but some good ones are worst possible idea, Scamper, Crazy Eights, et cetera. There are a lot of options here, but the most important thing is to go into the brainstorming with a what else approach. Never say no, focus on rapid fire, focus on producing a volume of ideas. And the reason why this is really important is that, one, you want to challenge your assumptions. So for every assumption, develop a hypothesis, and based on that hypothesis, see what solutions you could produce. That will help you get into a really creative space to start exploring many different creative solutions to the various different problems that you've identified in previous phases. And it also helps you reframe problems. So as you get into a brainstorming mindset, rethinking the problem, reviewing it from every different lens, every different angle as possible, really helps you, again, think very creatively and identify innovative solutions. And really push the boundaries. So you want to make sure that you're not defaulting to the first solution, which, as builders, we all get really excited about the solution, and we get really excited about the math or the model or the product that springs to mind first. And it's really easy for people to get hung up on one particular solution, even when that solution might not necessarily be the optimal one for the problem that you're trying to solve. And so it's really important here to force people out of that bad habit, to really try and push the boundaries, expand and explore all of the various different options that they can think of at this phase. The next phase is to dive into prototyping. And so prototyping, again, lots of resources online about different prototype approaches. Some of my favorites are building paper wireframes, building higher fidelity mockups, running painted door tests in production. If you're building process-oriented workflow products or systems, think about running manual tests. How can you test a new process in the real world? If you were to reorient or reorder steps in that process, how could you test that and run, other lightweight experiments in production? And here, really, the goal is to start testing your hypotheses, start validating some of the various different solutions, and use them in the real world. Again, the real world is very unpredictable. And the way to accelerate your learning is to figure out the most lightweight way to test a concept, run it in production, see how humans and other systems actually interact in real world. And the last step, but definitely not least, again, not always the last step, it can be happening in parallel with some of the other phases, is to really focus on testing and refining your solution. And so typically what this looks like is additional larger scale tests of your original prototypes that you tested in the previous phase, and test more comprehensive solutions. So again, there can be very complex interactions between products or systems, and this is an attempt to get you one step closer to a fully scaled product, to better understand whether or not there are going to be any unintended consequences or outcomes, and to really understand how something plays out in production. And why, again, really refine your solution based on your learnings. So you're going to learn a lot in the prototyping phase, and this will help you just zero in on some of the solutions that showed the early promise. And this will allow you to adjust for unexpected and missed use cases. Again, going back to the first phase of empathizing and developing a deep understanding, as you continue to test and iterate, you'll continue learning more about your process and your product. And this will also help you adapt to user and system interactions. So again, as those complicated systems and outcomes are produced, this gives you a way to see how those play out in reality and adapt your solution before committing too many resources upfront in the full build out and productionalization. And so again, going back to seeing how all of these play together, really in summary, the 5 key steps are to empathize, to develop a deep understanding of the humans involved in your product or in your process, or that may be impacted by your product, to define the human-centered problem statement, to make sure that you're really taking a step back and defining what outcome you're trying to produce, what problem you're trying to solve. Go through ideation to generate a large volume of ideas, brainstorm different solutions. The next step to prototype, test and validate some of those solutions in production with users, see what they look like, and then test to continue refining your product, continue refining your solution, and validate that it actually produces all intended outcomes, and you identify unexpected use cases that you can use to further refine your product or offering. So ultimately, that's a lot to digest. I know it's a quick talk, but why is design thinking important? What does it get you? It really gets you a deeper understanding of the problem space, the humans involved in your process, who interacts with your product. It helps you ultimately produce fewer unexpected outcomes because you spend more time upfront really getting to know the space and the context within which a problem exists. It's really helpful for understanding some of the nuances that might come into play later down the road. Additionally, it leads to a higher success rate and a faster path to success. So the more iteration, the more learning, the more context and testing that you focus on, the more likely you are to succeed. And I'll leave you with this last quote from Tim Brown, one of the co-founders of IDEO, about design thinking, which is, design thinking taps into capacities we all have, but that are overlooked by more conventional problem-solving practices. Nobody wants to run a business based on feeling, intuition, and inspiration, but an over-reliance on the rational and the analytical can be just as dangerous. The integrated approach at the core of the design process suggests a third way. I think this is really important, particularly for the AI industry to be aware of, because we are highly scientific, highly rational, and it's really easy to forget that design thinking in the human does play a huge role and is really critical. At the end of the day, we're all solving problems for humans, and it's really important to take a step back and leverage mechanisms like design thinking to reorient around the user. So that being said, looking forward to hearing all of your questions in the platform, and I hope all of you enjoy the rest of your sessions. Thank you.